What if one of the world's most strategically pressured nations, a country smaller than New Jersey, surrounded by adversaries, and perpetually dependent on foreign energy, is quietly engineering the most powerful energy source ever conceived by human science? Fusion energy, the same process that powers the sun, has long been considered the holy grail of modern physics, a promise of unlimited, clean, and catastrophically powerful energy that no nation has yet fully unlocked, but whispers emerging from Israel's secretive defense research corridors, its world-class universities, and its deeply classified military academic partnerships, are raising a question that very few in mainstream media are willing to ask directly. Is Israel not merely pursuing fusion for electricity, but for strategic military dominance? The answer, as we are about to explore, is far more complex and far more consequential than you might imagine. Israel has always existed in a state of strategic vulnerability that most nations cannot fully comprehend. And nowhere is that vulnerability more acute than in the domain of energy. Surrounded by nations that have historically controlled vast petroleum reserves, Israel has spent decades engineering its way out of dependency through solar desalination, offshore natural gas extraction in the Leviathan field, and aggressive investment in renewable infrastructure. However, none of these solutions offer the kind of energy independence that fundamentally alters a nation's geopolitical posture. Fusion energy, which generates enormous power from hydrogen isotopes without long-lived radioactive waste, represents something qualitatively different, not merely a cleaner fuel source, but a potential civilizational lever that could rewrite the rules of energy and power entirely. To understand why fusion matters so profoundly at the military and strategic level, one must first understand what it is at the scientific level, because the popular imagination has distorted it into either a utopian fantasy or an abstract physicist's dream. Fusion is the process by which two light atomic nuclei, typically isotopes of hydrogen called deuterium and tritium, are forced together under conditions of extreme heat and pressure, releasing vast quantities of energy in the process. Exactly as the sun does, every second of every day, unlike fission, which splits heavy atoms and produces long-lasting radioactive byproducts. Fusion is theoretically far cleaner, far more energy-dense, and critically, its fuel can be derived from seawater, a resource that Israel, sitting on the Mediterranean, possesses in abundance. What most observers fail to appreciate when examining Israel's technological capabilities is the extraordinary density of world-class scientific institutions concentrated within such a small geographic footprint, many of which operate with deliberate opacity when it comes to defense-adjacent research. The Weizmann Institute of Science, the Technion, Israel Institute of Technology, Hebrew University, and Ben Gurion University collectively produce per capita scientific output that rivals the largest nations on Earth, and many of their physics, plasma science, and high-energy research programs have documented connections to defense funding streams. The Israeli Ministry of Defense operates its own advanced research arm, known as MAFAT, which functions in a manner analogous to America's DARPA, funding high-risk, high-reward scientific exploration that sometimes surfaces only decades later in the public domain. The leap from fusion as an energy source to fusion as a military instrument is not as large as the casual observer might assume, and history provides sobering context. Thermonuclear weapons, which devastate entire cities in a fraction of a second, already operate on fusion principles, triggered by an initial fission explosion. What is less discussed, but increasingly relevant in advanced defense circles, is the spectrum of intermediate military applications that compact fusion research might unlock, including directed energy weapons that require enormous and sustained power supplies, electromagnetic pulse systems, and next-generation propulsion platforms for naval and aerial vehicles. A nation capable of producing reliable high-density fusion energy on a deployable scale would possess a strategic asymmetry so profound that it could neutralize conventional numerical disadvantages in a manner no other technology currently promises. While Israel maintains extraordinary secrecy around its defense-related scientific programs, there are documented and publicly available signals that plasma physics and high-energy research are active areas of institutional investment. Israeli researchers have published peer-reviewed work on plasma confinement, high-power laser systems, and inertial confinement approaches to fusion, several of which have been co-authored with researchers at institutions known to work on dual-use technologies. Israel has also been an active partner in international high-energy physics collaborations, including programs with the European Union's research framework and bilateral partnerships with American national laboratories, some of which touch directly on the frontier of fusion ignition science and high-intensity laser plasma interaction research. Any serious analysis of Israel's relationship with advanced weapons-adjacent science must reckon with the extraordinary precedent set by the Negev Nuclear Research Center near Dimona, a facility whose very existence was denied for years, and whose full scope of activities remains unacknowledged by the Israeli government to this day. Israel's policy of deliberate ambiguity, never confirming, never denying, has served it as a powerful strategic deterrent for decades, and it establishes a clear institutional comfort with conducting transformative scientific programs entirely beneath the threshold of public acknowledgement. This precedent makes it not only plausible, but historically consistent that a fusion-adjacent military research program could exist, be funded, be staffed by some of the world's most talented physicists, and remain entirely invisible to conventional journalistic investigation or open source intelligence analysis. To understand why Israel would have compelling incentives to pursue fusion at the military strategic level, one must appreciate that the broader global race for fusion is accelerating at a pace that no major power can afford to ignore. The United States achieved fusion ignition at the National Ignition Facility in California in December 2022, a moment widely described as a scientific milestone of generational significance. China is simultaneously investing tens of billions in its own fusion infrastructure, including the EAST and HL-3 tokamak reactors, and has explicitly framed fusion development as a component of its long-term strategic competition with the West. For a small nation acutely sensitive to regional and global power balances, remaining absent from this race would be a profound strategic miscalculation. One of the most reliable indicators of a nation's strategic scientific priorities is the behavior of its private capital ecosystem, and Israel's venture and deep tech investment landscape has shown growing interest in fusion-adjacent technologies. Israeli deep tech funds have invested in companies working on high-temperature superconducting magnets, a critical enabling technology for compact tokamak fusion reactors, as well as advanced plasma diagnostic systems, and high-powered pulsed power systems that have both civilian energy and potential defense applications. Several Israeli technology entrepreneurs with known connections to the defense establishment have made public statements about the inevitability of fusion commercialization, language that closely tracks the rhetoric used in American and British defense adjacent fusion startup ecosystems, suggesting an awareness of military applications that goes beyond casual scientific enthusiasm. Any honest examination of fusion energy in the military context must engage seriously with the profound ethical and proliferation questions that such a development would raise. Because fusion is not merely a technical achievement, it is a geopolitical transformation with implications that extend far beyond any single nation's borders. If compact fusion technology were successfully weaponized, or used to power weapons platforms of unprecedented capability, the existing frameworks of arms control, non-proliferation treaties, and strategic stability already under severe strain, could fracture entirely. The international community has spent decades constructing norms around nuclear weapons, precisely because of their existential potential, and fusion-powered military systems could raise analogous concerns, while existing in a legal and normative vacuum that the international community has not yet begun to address with the seriousness the question demands. The honest answer to the question at the heart of this investigation, whether Israel is actively developing a military-grade fusion energy program, is that we cannot know with certainty, and that uncertainty itself, in a deeply strategic sense, is precisely the point. What we can say with confidence is that Israel possesses the scientific infrastructure, the institutional culture of secrecy, the geopolitical motivation, and the historical precedent to pursue exactly this kind of program, if its strategic planners concluded that the moment demanded it. The global trajectory of fusion science, accelerating toward practical ignition and eventual deployment, means that this question will not remain theoretical for long, and nations that are asking it today, seriously and rigorously, will be better prepared than those who waited for public confirmation before beginning to understand what was already quietly underway. Before you leave, this conversation is just beginning. If this deep dive resonated with you, then consider what it means that this topic receives so little mainstream coverage, and what other questions are waiting just beneath the surface of the official narrative. Subscribe to this channel if you want to be part of an audience that refuses to accept shallow analysis of complex global realities. Share this video with someone who you believe is ready to think at this level, and leave a comment below with the one question this video raised for you, that you most want answered next, because your questions shape what we investigate, and the most important conversations are always the ones that keep going long after the video ends.